Hello everyone. So our next question of ionic equilibrium, it is 46. We have done questions up to 45 in our previous lectures. Now today we will start with question number 46. Okay. So what was the question? Question is the ionization constant of acetic acid is given to you. It is 1.74 into 10 raised power minus 5, right? So calculate the degree of dissociation of acetic acid in 0.05 molar solution, and also calculate the concentration of acetate ions in the solution and pH of the solution. So very simple question. See, we have acetic acid, okay? So acetic acid, it gives acetate ion along with H plus ion, right? Wait for 1 minute. Okay, so acetic acid gives acetate ion and H plus ions, right? Now we have dissociation constant 1.74 into 10 raised power minus 5 Ka. It is 1.74 into 10 raised power minus 5, and solution has 0.05 molar. Solution is 0.05 molar, means it is the initial concentration. Okay, so initial concentration of acetic acid is 0.05 and acetate ion and H plus ion 0 initially. Now at equilibrium, so at equilibrium, if alpha is degree of dissociation, you can write initially, let alpha is the degree of dissociation. So it becomes 0.05 into 1 minus alpha. So it is 0.05 alpha, 0.05 alpha. Am I right? Now say, what is Ka? Ka equal to acetate ion concentration, H plus ion concentration divided by acetic acid concentration. So it is 0.05 alpha into 0.05 alpha divided by 0.05 into 1 minus alpha. And you know, as Ka is very less, see, it is 1.74 into 10 raised power minus 5. It is very less, so alpha can be neglected, okay, as compared to 1. So what would we get? Obviously 0.05 cancel, and 1 minus alpha is round about 1. Okay, because Ka is very less, that's why we can neglect it. Alpha can be neglected as compared to 1. So it becomes 1.74 into 10 raised power minus 5 is equal to 0.05 into alpha square. So alpha square equal to 1.74 into 10 raised power minus 5 divided by 0.05. So in this way, what would we get? What is alpha now? Because we have to calculate degree of dissociation. So alpha is, alpha square simple, it is equal to, yes, 174 over 5. Yes, questions are same, but say we need practice, okay, so that we are used to these type of problems. Okay, so alpha square is, yes, okay, 5 3s are 15, 24. So 5 4s are 2048. So it is 34.8 into 10 raised per minus 5. So what is alpha then? Yes, what is alpha? Alpha is, see, 348 into 10 raised per minus 6 raised to power 1 by 2. So it is 9.33. Okay. I think it's not the answer, beta. What is the square root of 348? Square root of 348. It is 18.65, or we can say 66 into 10 raised to power minus 3. This is the alpha. Value of alpha is degree of dissociation. This is the degree of dissociation. Now next question is calculate the concentration of acetate ions. Okay, and pH. So concentration of acetate ion is, it is same as that of H plus ions. Okay, or you can write simply acetate ion concentration, that is 0.05 into alpha, that is 0.05 into 18.66 into 10 raised per minus 3. Okay, so this into 0.05, now it is 9.33 into 10 raised per minus 4. So acetate ion concentration is 9.33 into 10 raised per minus 4. So same is the concentration of H plus ion. So concentration of H plus ion is also equal to same 9.33 into 10 raised per minus 4. Okay. Now what is the next question? Calculate the pH. So what is pH? pH is negative log of H plus ion, that is negative log of 9.33 into 10 raised per minus 4, right? So that implies it is minus log of 9.33 minus log of 10 raised per minus 4. So it becomes 4 log 10. Log 10 is 1. So that is equal to 4 minus log of 9.33. So what is log of 9.33? Yes. So number of digits before decimal place is only 1. So it is 0. Now 93 and 3. So value is 0.97 almost. So it becomes 3.03. So this is the pH. That's it. Okay, beta. Yes. Square root of 324. Yes. Okay. So that's the question number 46. Now question number 47. Yes. So question number 47 is, it has been found that the pH of 0.01 molar solution of organic acid is given to you, that is 4.15. So calculate the concentration of the anion, ionization constant of the acid, and the pKa. See, pH is given to you. So from the pH you can calculate H plus ions. Okay, and as it is an organic acid, it is not mentioned it is monobasic or a dibasic, but if it is nothing is mentioned, we should take it as monobasic. So let us say acid is Ha. So it gives H plus ion and A negative ion. This is the anion. Okay. Now, if concentration of Ha is C, or it is given, so write it like this only, 0.01 molar initial concentration. Okay, it is 0. Say there is no need to calculate degree of dissociation. So at equilibrium, let us say X moles undergo dissociation. So 0.01 minus X. So it becomes X and X. Right? X is 0.01 alpha. Okay? If alpha is taken as degree of dissociation. Here we suppose that X mole per liter of HA dissociates at equilibrium, because there is no need to calculate alpha first, because it is not asked to calculate alpha. Okay, so just we write it as X and X. Okay, now pH is given to us. That means from the pH, let us calculate H plus ion concentration. So it is 4.15. That implies log of H plus ion concentration is equal to minus 4.15. Okay, so what is H plus ion concentration? That is equal to anti-log of minus 4.15, but we cannot calculate anti-log of negative number. So what we do, we take it as minus 4 minus 0.15. Now minus 4 minus 0.15 plus 1 and minus 1. So it becomes minus 5 plus 0.85. Means decimal part should be positive. So it is 5 bar 0.85. It means minus 4.15 can be written as 5 bar 0.85. But it means that the number 5 is of the negative value, is a negative value, and 0.85 is a positive value. So it becomes anti-log of, yes, anti-log of 5 bar 0.85. So it is into 10 raised to power minus 5 and anti-log of 0.85. So it is 707.08. Okay, so this is the concentration of H plus ions, and same is the concentration of anion. So what is concentration of anion? So concentration of anion, that is A negative ion, is equal to 7.08 into 10 raised to power minus 5 molar. Okay, because concentration of H plus and A negative is same. Now next is calculation of ionization constant. So what is Ka? Ka equal to H plus ion concentration, A negative ion concentration over HA concentration. So it is equal to, yes, X into X divided by 0.01 minus X. 0.01 minus X. Now say concentration of A negative ion is very less. That means X is very less as compared to 0.01. So it can be written as X into X divided by 0.01, because 0.01 minus X is very close to 0.01. Okay, because X is very small. Okay, as x is very small value. Okay, now what is x? It is 7.08 into 10 raised per minus 5 into 7.08 into 10 raised per minus 5 over 0.01. So what is the result? The value comes out to be 7 7s are 49, means round about 5. Okay, so 5.0 into 10 raised to power minus 7. Okay, because see 7 7s are 49 and it is 7.08 into 7.08, so almost 50 into 10 raised per minus 8. Okay, so 5.0 into 10 raised per minus 7. So this is Ka. Now to calculate pKa, next part is to calculation of pKa. This is dissociation or ionization constant of acid. Now what is pKa? pKa equal to minus log of K, that is minus log of 5.0 into 10 raised per minus 7. So that is equal to minus log of 5 minus log of 10 raised per minus 7. So it becomes 7 minus log of 5. That is 7 minus 0.699. Log 5 is 0.699. Okay. So value is 6.301. So this is the pKa value. But any doubt up to this? Yes, anybody? Any doubt up to question number 47? If you have any doubt, please do ask. Okay. Now question number 48. Assuming complete dissociation, calculate the pH of the following solutions. See, it is already mentioned complete dissociation. Okay, great, beta, great, very good. Okay, so first is HCl. So on complete dissociation, yes, you can demand logarithm table or you can bring it with you. Okay, you can carry this log table along with you and ask the examiner that please give it to me whenever I need it. Okay, otherwise it should be there with the examiner. Okay, but don't write anything on the log table. Okay. So HCl give H plus and ACl negative ion, sorry. So on complete dissociation, concentration of HCl, that is 0.003. Complete dissociation means it becomes 0, it becomes 0.003, 0.003. Alpha is 1 now. That means on complete dissociation, HCl concentration is equal to H plus ion concentration. So it is 0.003 molar, or you can write 3 into 10 raised to power minus 3 molar. So what is pH now? It is for A. pH is minus log of H plus ion. So it becomes minus log of 3 into 10 raised to power minus 3. So it is minus log of 3 minus log of 10 raised to power minus 3. So it becomes 3 minus log 3, because minus 3, this minus 3 come on this side and minus minus plus. So plus 3 log 10, and log 10 is 1. So what is the value of log 3? it is 0.477. So it is roundabout, see, 7, 3, 10, 5.323. So this is the pH of the solution. Am I right? Yes, beta. Is it okay? Three minus 0.477. So 2.5 to 3. Okay, now B part. 0.005 molar. Okay, good. 0.005 molar sodium hydroxide. Then it is 0.002 molar HBr, 0.002 molar KOH. Beta, do it by your own. I will help you out, but you should solve it before me. So 0.005 molar means, and complete dissociation, that means concentration of NaOH, because one NaOH will give one OH negative. So concentration of NaOH is equal to concentration of OH negative, and that is equal to 0.005 molar, means 5 into 10 raised to power minus 3 molar. Okay, so from here we can calculate POH. Rather than calculating H plus first, you can do it by two methods. Okay, I am doing first one, POH. So to calculate POH is minus log of OH negative, just like pH, that is minus log of H plus. So it is minus log of 5 into 10 raised to power minus 3. So it becomes minus log of 5 minus log of 10 raised to power minus 3. So POH equal to minus 0.699 plus 3. Okay, so it becomes 2 point, yes, what is the value? 2.3 minus 0.699, 2.301. okay, that is POH, and we know that pH plus POH equal to 14. So from here take it as 2.3. okay, so pH is equal to 14 minus POH. okay, so that is 14 minus 2.3, that is 11.7. That's it. Or second method is, first calculate OH negative ion concentration, H plus ion concentration. You know, ionic product of water, H3O plus ion concentration into OH negative ion concentration, that is equal to Kw, and H3O plus ion concentration is Kw over OH negative ion concentration. So Kw is 10 raised to power minus 14 divided by 5 into 10 raised to power minus 3. So from here it becomes 2 into 10 raised to power minus 12 molar. So in this way pH equal to minus log of H3O plus ion, that is minus log of, yes, 2 into 10 raised to power minus 12. So it becomes minus log of 2, okay, minus log of 10 raised to power minus 12. So it becomes, yes, 12 minus log 2, right? That is 12 minus 0.3010. So round about 11.7. That's it. Next question, two questions, that is C and D, that you should do by your own and write the result in comment section. I will read only comments, okay? C and D. D is 0.002 molar KOH. They are very similar. See, instead of HCl there is HBr, instead of sodium hydroxide there is potassium hydroxide, and there is a change in concentration only. Method remains same. Okay, so do it and write the values in the comment section after the class. Okay, right? So let's proceed to the next question, that is question number 49. Okay. What is the question number 49? Calculate the pH of the following solutions. A. 2 gram of thallium hydroxide dissolved in water to give 2 liter of solution. Say, whenever this question comes in your exam, atomic weight of thallium, there it should be given to you. Don't worry. Okay. So now let us calculate pH of 2 gram of thallium hydroxide which is dissolved in water to give 2 liter of solution. Okay. So first of all we have to calculate molarity of thallium hydroxide. Okay. Yes. So what is molarity of thallium hydroxide? You know, to calculate molarity means concentration, it is equal to number of moles of thallium hydroxide divided by volume of solution in liter. And number of moles are not given, but weight is given. Okay, so it is weight of thallium hydroxide over molecular weight of thallium hydroxide divided by volume of solution in liter. So weight is 2, weight given, it is 2 gram, and molecular atomic weight of thallium, that should be given to you, it is 204. Okay, plus O, oxygen is 16 and hydrogen is 1, so 17, and what is the unit? Gram per mole divided by 2 liter, right? So just solve it. What is the value? 2 divided by, yes, 221 over 2. So what is the value now? See, 1 divided by 221. So it is actually 1 upon 221 molar, that is 4.525 into 10 raised to power minus 3 molar. This is the concentration of thallium hydroxide. Now thallium hydroxide is monoacidic base, so thallium hydroxide in aqueous solution, because it is dissolved in water, so it becomes thallium 1 plus aqueous OH negative ion aqueous, and nothing is mentioned, so we consider it as it is completely dissociated. So concentration of thallium hydroxide is equal to concentration of OH negative ions, and that is equal to 4.525 into 10 raised to power minus 3 molar, right? So let us calculate POH. So what is POH? POH is minus log of OH negative ion. That is minus log of 4.525 minus, sorry, it is like this, okay? So that is minus log of 4.525 minus log of 10 raised to power minus 3. That is 3 minus log of 4.525. If you have any doubt, please stop me. Okay? You can stop me anywhere. Okay, so what is the log of 4.525? Log of 4.525, yes. Log table, I don't have. Oh, yes, I have. Okay, so 3 minus 0. Yes, go to 45 and then 45, say at 2. At 2 it is 6551, okay? 6551. And then 5 mean difference. So mean difference of 5 is 5 only. So it becomes 6556. 6556. Okay? 6556. So value is, yes, 3 minus 0.6556. So it is 2.344. So what is pH? We know that pH plus POH is 14. That implies pH is equal to 14 minus POH. So 14 minus 2.3444. So it is equal to 11.6556. So this is the pH of the solution. Or if you don't want to go like this, first calculate H3O plus ion concentration and then calculate pH. Okay? Similarly, you can do other questions. Can you? Yes, beta. Can you do other questions? Let us do one more. That is B. Okay. So B part is, we have 0.3 gram of calcium hydroxide. And this is dissolved in water to give 500 ml of solution. Okay. 500 ml of solution. Right. So first of all, we have to calculate concentration of calcium hydroxide. So to calculate concentration of calcium hydroxide, what is mass of calcium hydroxide? It is 0.3 gram. And what is the molar mass of calcium hydroxide? Calcium is 40 and 17 into 2, 34, means 74. So molecular mass of calcium hydroxide is 74. Mass over molar mass over volume. If volume is in ml, so into 1000. Okay. So it becomes, say, 500 and 1002. So 0.3 into 2 over 74. Okay. So it is 0.6 over 74. Okay. means it take it as 600 over 74 into 10 raised to power minus 3. So what is the value? 600 divided by 74. It is 8.1 around. So 8.1 into 10 raised to power minus 3 molar. Now, calcium hydroxide, one molecule or 1 mole of calcium hydroxide will give 2 moles of OH negative ion. Means concentration of OH negative ion is just double. Concentration of OH negative is 2 times concentration of calcium hydroxide. Am I right? It is 2 times. This is the trick here. Okay. OH negative ion concentration is not equal to concentration of calcium hydroxide. It is 2 times, double the number. It is double the number. Okay. Why? Because 1 mole of, or we can say 1 molecule of calcium hydroxide will give, yes, 1 molecule of calcium hydroxide will give 2 molecules of OH, 2 ions of OH negative. Okay. So it is 2 into 8.1 into 10 raised to power minus 3. That is 16.2 into 10 raised to power minus 3 molar. Okay. So what is OH negative ion concentration now? Sorry, POH. POH is minus log of OH negative ion concentration. So that is minus log of 16.2 into 10 raised to power minus 3. Again same funda, minus log of 16.2 minus log of 10 raised to power minus 3. So it is 3 minus log of 16.2. Okay. So that is 3 minus, yes, 16 and 2 means 1.209 around. Okay. So it becomes 1.791. So that is POH. But we have to calculate pH. Again, pH plus POH is 14. So pH equal to 14 minus POH. That is 14 minus 1.791. So it is around about 12.21. That's it. Okay. So again, C and D you have to calculate and write the result in the comment section. They are similar to it. Can you do it? Yes, beta. कर सकते हो? Yes, anybody? Yes, very good, Abhay. Okay, all of you should write the answer after watching this video. Okay, in the comment section. Means question number 48, C part. This is the answer. Question number 48, D part. Write the answer. Question number 49, C part and D part. Okay, you should write the answer. Okay. Okay, D part is something different, huh? So let's do. Okay, C part you should do. Okay, I will do D part. Okay, C part you should do. Okay, D part is 1 ml of 13.6 molar HCl diluted with water to give 1 liter of solution. Means we have to apply dilution formula, okay, to calculate the molarity of the resulting HCl solution first. See, apply dilution formula. what is dilution formula? Dilution formula is M1V1 is equal to M2V2. M1 is 13.6, okay, and volume is 1. M2 we have to calculate, and volume is 1 liter, means 1000 ml. Keep in mind, if volume V1 is in ml, V2 should be in ml, okay. So M2 comes out to be 13.6 into 10 raised per minus 3, or you can write in scientific notation 1.36 into 10 raised per minus 2 molar. Okay. Okay, then rest is, you know, HCl will give H plus and Cl negative. So H plus ion concentration is same as that of HCl concentration. So that is equal to 1.36 into 10 raised to minus 2. So nothing is in the question. What is pH? Minus log of H plus, that is minus log of 1.36 into 10 raised to minus 2, that is 2 minus log of 1.36, that is 2 minus log of 1.36. So what is log of 1.36? Log of 1.36 is, yes, 0.1335. So value comes out to be 1.867 around, okay, or we can say 65, okay. That's it. Okay, so C part you should do, okay. Okay, question number 50. The degree of ionization of 0.1 molar bromoacetic acid solution is given to you, that is 0.132. So calculate the pH of the solution and pKa of bromoacetic acid. First, what is bromoacetic acid? Bromoacetic acid. First, write the acetic acid. You know, acetic acid means ethanoic acid, that is CH3COOH, okay. So bromoacetic acid means one of the H is replaced by, one of the H on the carbon is replaced by bromine. So this is bromoacetic acid, okay. So bromoacetic acid is also a monobasic acid, right? It is monobasic acid. So initial concentration, it is given to us, that is 0.1 molar. So it is 0 initially. Now at equilibrium, so at equilibrium it is 0.1 minus X, okay, because we, okay, degree of ionization is given to us, so we should write it in terms of degree of ionization, that is 0.1 into 1 minus alpha is equal to 0.1 alpha, 0.1 alpha. Now keep in mind, now don't neglect alpha, because alpha is not very small as compared to 1, okay. It is simple 0.132, okay, 0.132, okay. Now at equilibrium, this is the thing. So from this, what is Ka? Ka is bromoacetate ion concentration into H plus ion concentration divided by bromoacetic acid concentration. So that is 0.1 alpha into 0.1 alpha divided by 0.1 into 1 minus alpha. Okay. So now see 0.1, 0.1 cancel. So it is 0.1 into alpha square over 1 minus alpha. So it is 0.1 into 0.132 raised to power 2 over, yes, over 1 minus 0.132, 1 minus 0.132. So what is the value now? Yes, can you calculate? See 0.1. So what is the square root of 0.132? Yes, 0.132 into 0.132. So it is 0.0174 divided by, yes, 1 minus 0.132, that is 0.868. So yes, what is the value now? Yes, beta. 0.001. Okay, take it as 17.4 over 8.68. Yes, into, see, 17. So 8.68, 0.1. So it is into 10 raised to power minus 3. So it is 8. Yes, what is the value? 17.4 and 8.68. So very close to 2, right? 2 into 10 raised to power minus 3. So this is the value of Ka. Now to calculate pKa, we have to calculate pKa as well as pH. Okay, so this is actually Ka. Okay, so from Ka we can calculate pK. pK is minus log of Ka. So that is minus log of 2.0 into 10 raised power minus 3. So it is minus log of 2 minus log of 10 raised power minus 3. So what is minus log 2? Minus 0.3010, and minus log of 10 raised power minus 3, it is 3. So 3 minus means it is around about 2.7. Very close to 2.7. So this is pKa for this particular question. Now pH. See, H plus ion is 0.1 into alpha. So H plus ion concentration is 0.1 into alpha, that is 0.1 into 0.132, that is 1.32 into, yes, 10 raised power minus 2. So what is pH? It is minus log of H plus ion, that is minus log of 1.32 into 10 raised power minus 2. So minus log of 1.32 minus log of 10 raised power minus 2. So what is log of 1.32? So log of 1.32 is 0.1206 plus 2, means value comes out to be very close to 1.88. So this is pH of the solution, and this is H plus ion concentration. So these are 3 answers. Yes, beta. Any doubt up to this? Chemistry with DNA. Thank you so much, beta. Okay. Any doubt up to this, beta? Yes. Okay, so today we have completed 50 questions. We have left with 23 questions. Okay. So I will stop here today. And you should give me answers in the comment section of question number 48 C and D part and question number 49 C part. Right? So bye bye beta. God bless you all.